So now instead of looking at X and Y grid, now we're looking for X, Y, and Z grid. Now we're looking at three-dimensional space. And so what we really are looking for, we're looking for a little individual point in this whole three-dimensional space that is going to interact with, they're no longer lines anymore either. We call them planes, but they're, if you think about it, they're almost like a little sheet of paper. So what we want to do is we want to sort of find this right here, like this little blue line and the blue sheet of paper, the green sheet of paper and the white sheet of paper. We're trying to figure this one little individual point where they all cross. Do they have to cross? Not at all. Could be that they're all parallel to each other. Could be that they do cross, but they actually cross in a line as opposed to an individual point. And at that point, I still don't know what this system is. Okay. All right. Could be that one plane crosses the other two, but the other two don't cross each other, though. So it's going to be, I can't even know the equations here anymore. So we'll see what happens here. All right, we got, let's see, we've got 15 minutes here. I'm going to go through this kind of quickly here. So stay up if you can here, but we're going to do this kind of quickly here. So I got three equations. There it is. 1, 2, 3. I also have three variables, X, Y, and Z, because now we're dealing with three-dimensional space. Here's what we got to do. We got to boil this down so that we get rid of one of the variables down to two variables. And from two variables, we're going to go down to one variable. So we're sort of going to go backwards here. So what do? Take two individual equations. It doesn't matter which one's which, but we have to decide on which variable do we want to get rid of first before we do anything. So actually they're almost all the same. X's look pretty easy to get rid of. The Y's also get easy to get rid of. Here we're going to multiply this by 2 to get these guys opposites. The Z's also easy to get rid of. I'm going to just choose the Z's. Let's get rid of the Z's first. So I'm going to pick two individual equations here. I'm going to pick the top one and the middle one. Hey, that's kind of cool. Look, the Z's are already opposites of each other. Okay, cool. Let's go like this then. Let's move it over here without changing anything. There's no multiplier to do. So I'm going to move this over. Nothing to multiply by because the Z's are already opposites of each other. And I'm going to add down. So I got, let's x plus x is 2x. 2y plus 1 more y is 3y. The Z's are gone because that's the way we planned it in the first place. And 2 plus 6 is 8. So there it is. Grab two individual equations. Or choose which variable we want to get rid of first. Then grab two individual equations. Okay, that's all done. Now we go back and we're going to grab another two equations. So now it could be either the first one and the last one, or it could be the middle one and the last one. It doesn't matter. But you may want to think about what do you need to multiply by. I think I want to choose the middle one and the last one, because I have to multiply this guy by a positive 2. I'll get myself an opposite. So multiply the middle equation by 2, which makes a negative 2z here. That'll be the exact opposite of this positive 2z for the third equation here. So 2x plus 2y now minus 2z is equal to 12. Everybody good there? The third equation does not change at all because we already have those opposites here. So x minus y plus 2z is equal to negative 7. Add those up. 3x looks like plus y. The z's are gone as planned. How about a 5? Alright, if you notice, we just went back down to what we were doing in 4.1. Now I got this equation, this equation. Now I got two equations and two variables. So now we're going to finish it up just like we did in 4.1. I'm going to write these guys down and I'm going to work with these guys to get rid of one of the variables, and bless you. Okay, what should we multiply and which one to get opposites? Perfect. The bottom one, -3, because if I do that, then I get myself an opposite of this +3 here. So top stays the same, no change, but the bottom gets multiplied by -3. So 2x plus 3y equals 8. Let's see, -9x minus 3y, -15. The y's are gone, as planned. How about divide through by -7 both sides? How about x equals 1? Now, our little problem is this x equals 1. I can't plug it back into my original, because notice if I know what x is, I still have y and z that I don't know. So what we do, we sort of just start climbing back up the ladder. We can plug in the x into this one or this equation, and then we'll know our y value. Once we know our y value, then we can plug into the original. So sort of go backwards on our... Doesn't matter which one you choose. I just chose the little bottom one right over here. So 3 times 1 plus y equals 5. So what should y equal then? Subtract 3 from both sides gives you y equals 2, and I know that one. Now I can finally go back and plug into one of my original equations, and it does not matter which one to get my z value. I'm going to choose the top. Top equation, x now is a 1 plus 2 times 2 for the y plus z is equal to 2. In this case, 4 plus 5, it's 5 on one side, still a 2 on the other. Subtract 5 from both places gets you -3. There's my third variable, and now I got to write it. I always have to write as x, then the y, and then the z value. Now this is called an ordered triplet, not a coordinate pair, but a coordinate triplet or an ordered triplet. Okay, let's do one more, and then we'll look at the special cases real quickly here. So if you can stay ahead of me, go for it. If not, at least keep up with me here. Okay, so before we start, we got to think about which variable do you want to get rid of first. I prefer getting rid of z's unless it's tough, and then I move on to something else. But I'm going to just choose z as well for this one. So then I got to just choose individual two pairs of equations here. I'm going to sort of keep it the same. I'm going to choose the first one and the second one. So if I'm going to get opposites, what should I do? Perfect. Multiply by a -3 on this top equation here, because I want to give myself a -3z right there. Okay, if I do that though, I got to multiply -3 on every single one of those coefficients here. So then I got a -9x plus 6y minus 3z is equal to a -6. The bottom equation stays exactly the same, no changes there, because I have my opposite. Alright, so adding up, -9 and 3 makes a -6x. How about a 7y, and the z's are gone, and a 1 on that side. Okay, have to go back here and got to choose two. I have to use another pair, or a different pair of equations here. Yeah, top and bottom seems to be a good one here. Top and bottom, it's positive z, minus z. I don't need to change anything at all. I'm going to rewrite them here on the bottom. And the bottom equation here, minus z plus 4. And add them up, see what happens here. Alright, so 4x, let's see, minus 2y, the z's are gone, equal to 6. Alright, one little extra bit here that we can do. Notice the 4, the 2, and the 6. Notice that all these guys are even numbers. So before we start putting these together over here, we can always reduce. As long as everything reduces, doesn't 2 go to all those? So I got myself 2x plus y is equal to 3. Makes it a lot easier to sort of work with. So now let's bring it together. Negative 6x plus 7y is equal to 1. And you know what? Before I put these guys together, can I just create the opposite already? What should I multiply by to get opposites? I'm looking about the x here. Yeah, multiply by 3. Right? Because if I multiply by 3, my 2x times 3 will give me a positive 6x, and I've saved myself a step. An extra step of working here. So as you put these two equations together, you may want to think about if I can get a sort of quick opposite right away. So 2 times 3 is 6x, y times 3 is 3y, and 3 times 3 is 9. Adding these guys up, notice the x is now gone, and I got myself a 10y equals 10. I do know what y is now. So y equals 1. Okay, and then now go backwards here. Can you tell me what x would be then? I heard 1, okay. If y is equal to 1, then we subtract 1 gets you a 2, and 2x equal to 2 gets you x equals 1. Perfect. And since you know x and y, can you plug in any one of those original equations? Give me what z would be. Still 1. Alright, this time I chose the middle equation. And again, it doesn't matter which one you choose. If you chose the top one, that's okay too. We should get still the same exact answer, which is z is also a 1. Okay, and then again, you still have to write it as an ordered triplet. So it's going to be 1, 1, 1. Okay, let me run through these. I've got 3 problems left, but they'll be pretty quickly here, so let's go through them. The 2 special cases, number 3 and number 4. Alright, looking at this problem here, again, I'm thinking to myself, which variable do I want to get rid of? I could try z again, that's fine. Z looks okay. I'm going to multiply this guy by 2 eventually and do that. So to get opposites here, I would have to multiply through by a negative 2 on top. If I do that, I get myself a negative 6x minus 10y plus 4z negative 2. On the bottom, no changes whatsoever because that already is going to have a negative 4z there. But as I do this, I notice something kind of weird. And as I add them up, I notice something even more weird. X's are gone, Y's are gone, Z's are gone, everything's gone on this side. At the same time, everything's gone on the other side. So sometime during the process, it doesn't have to happen in the first step, could be actually all the way down here on the second step, could be all the way down here on the third step. But somewhere along the line, you're going to get 0 is equal to 0 because everything just canceled. In that case, you got yourself, they say no unique solution, but really what you have is a dependent system, or you can say the infinite number of solutions. The last one is the sort of the one. Okay, good there. Let's jump to the next one here. I'm going to change the numbers just slightly on you. Number 4. Hopefully you have your match problems in front of you, so I have to write down the whole problem again. And notice you're going to do the exact same thing. You're going to multiply through by a -2 on top to get rid of the z's. So -6x plus 2y minus 4z equals -8. Bottom equation stays exactly the same. And as I add them up, again, this whole concept still works again. 0 is on that side, except this time you get a -6. And we say this guy right here, 0 with a slash through it. You could say no solution. Alright, you could say inconsistent system. Okay, good there. Just one more problem, we're out of here. Thanks for waiting just a little bit here. Sometimes what you have is sometimes you have missing variables. Like the first equation, you're missing a z. The second equation, you're missing an x. Third equation, you're missing a y. So have those on the homework as well. In this case, we're just going to still keep on doing the same thing here. So we're going to try to figure out, okay, what do these have in common? They have a y in common. The first two equations have a y in common. How can I get rid of the y? So I'll multiply the top by a 3. That'll give me a 6y. I'll multiply the bottom by a -2 because that will give me a -6y. So now you look at which ones they have in common. 3x plus 6y equals 0 for the top equation. And then I would leave a little bit of space for the z variable, just so it doesn't get so mixed up everywhere. I would sort of leave little columns here, one for x, one for y, and one for z. On the next one, no x's there. Write the y's underneath each other, the z's own separate column, and a 6 over here. Add them up. So the y's should cancel as planned, but you get a 3x minus 2z is equal to 6. Once you get to this step, notice what you have for the other equation. You only have x's and z's. So what you've done is you've got them down to 2 variables now only. That's a good thing. So let's write this underneath here. And the question is, can I get opposite signs right away? Or can I make opposites right away already? Can't do it for my x, huh? Maybe I can do it for my z though. If I can get a positive 2z over here, I got it. So how about multiply through by -2? So 2x times -2 makes -4x. Negative z times a -2 makes a positive 2 and a -10 at the end. Adding them up, I'm left with a -x. The z's are gone as planned and a -4, so x has to equal 4. And work your way up the ladder again here. I'm going to look over here, and this time you could have actually plugged into the top equation, get yourself the y value. You could plug into the bottom equation, get your z value first, whichever one you want. I chose to do the bottom value here, so 2 times 4 minus z equals 5. That'll make an 8. Subtract 8 from both sides gets you a -3, and change the sign gets you a positive 3. And now at this point it doesn't matter. You could choose the top equation, still plug in the x to get your y value. You could choose the middle equation, plugging in what you figured out for z to get the y value. Whichever way you want to do it. I plugged it into the middle equation here, so the 3 took over for the z value. Subtract 3 gets you -6, divide by 3 gets you a -2, and again, finally, ordered pair would be 4, -2, 3. All right, raise your hand if your brain hurts. Yes, that means you probably learned something today. All right.